Thanks for the solution, Animal. Yeah. I'll bet this lemma is probably useful in a lot of other problems. So now we're on the fifth problem. Oh, this one looks fun. So we have a parallelogram, ABCD. So I'm going to do it like this. And we have a point T so that ATB is an acute triangle. Isn't it great how Russian GEO just gets rid of degenerate cases, or just gets rid of all the special cases? I like it. That looks pretty acute to me. All right. Let O1, O2, okay, so we draw the circumcenters. We have three circumcenters, ABT, DAT, and CDT. Okay, so O1 is the center of C. Let's make sure I did. And then, let's see, I just drew them all at once. So yeah, O2 is the center of D. Whoops. Didn't mean to, I want to call it O2, 2. And O3 is the center of E. And we want to show the orthocenter of O1, O2, O3 lies on AB. All right, interesting. Let's see if I can make this look better. All right, 1 second, guys. I'll be right back. All right, thanks everyone for waiting. Let's see, a couple comments in the chat. See you, Arabian Math. Thanks for joining. So let's see. O1, O2, O3. We want to show the orthocenter lies on AB. So yeah, what's the best way to go about this? Let's see. So we have ABT, DAT, and CDT. So O2. Hold on just a sec.
Can we extend AD?
Can we extend AD? Hold on just a sec.
Yeah, the point of intersection of the other two circles looks like collinear with AD.
Yeah, it does. Yeah, let's see. That obvious. It's probably just an angle chase, right? Because angle CDE is, yeah, angle CDE is angle TCD. Oh, wait, is that obvious?
We can hide one of the circles if we want to prove this.
But yeah, I mean, these are parallel, so I think it's easy to prove. TE is equal to CD. Yeah, because ABTE is an isosceles trapezoid, so TE is equal to AB is equal to CD, and so yeah, that pretty much does it. Draw the line through O1 parallel to TB. Okay, so I'm gonna follow Serdar's suggestion. So O2, O3 is perpendicular to TB. And so yeah, if we draw the parallel through O1 to TB, and we let it meet AD at a point F, let's say. Yeah, I mean, basically we want to show, so if you have TA, TD, and TE, let's see.
Can we once connect O1, O2, O3 and try drawing the orthocenter?
Yeah, so F would be the orthocenter.
Yeah, I think it would be cyclic with something. Is F the orthocenter?
Yeah, F is the orthocenter.
O1, O3, EF. Is it cyclic? EF, O1, O3.
Let's see. Yes.
Yeah, it's cyclic. I think we just need to, or maybe we can let F be the intersection of this circle with AD and then try to prove that it's the orthocenter.
Okay. Hold on just a sec. So O1F is parallel to TF, and O3F is parallel to AT, and O2F is parallel to TE. So we have basically these three lines are parallel to these three lines. It kind of feels a little like a homophily, doesn't it? I wonder is F the midpoint of AE? That would be interesting. No, it's not.
I think I got it the way considering F as the intersection of the circle with AD.
Okay. Hold on just a sec. Let me hide some of the other lines for now. Whoops, sorry. Okay, so
yeah, we can name it, say H. Yeah, I wrote my angle K as in H.
Oh no, Hawk. Hold on just a sec. So no, O1 or okay. I'll first let Animal finish, and then I will look at what Hakan said. So you called it H here?
Yeah.
Okay. All right.
Yes, so HO3O1
Mm-hmm.
is equal to AeO1, because of the cyclic quadrilateral we have assumed,
Okay.
and ApO1 is 90 minus ATP, ATE.
Okay. AeO1 is 90 minus ATE.
90 minus ATE. Yeah. Is
Okay.
it good?
I think so. Let me write this out. But yeah, I think that does it. So yeah, someone else joined. I'm not sure who the someone is, but let me write out animal solution. Just a second. So let's. Well, okay. So first, I'm going to show that AD and E are collinear. So let me hide a couple things. Okay, so we want to let CDT meet ABC at E. Or hold on. Let CDT meet ABT at point E. Okay, so then we have AB is equal to CD. Okay, so yeah, how do we show AD and E are collinear? So CD is equal to AB, and is it obvious that TE is equal to AB? Or you know what, we could extend AD. I think it's easier to do it this way. Extend AD to meet the circle ABT at point E. I think that's an easier way to do it. Yeah. So I'll just write it the way Serdar said it. So I'll write it out in a little bit more detail. One sec, guys. I'm sorry. Sorry about this, but I have to. I'll be right back. All right. Thanks for waiting. I apologize about that. So, let me hide a few things. So, okay. So basically, if we hide that circle for now, then BC is parallel to AD. And that implies TE is equal to CD So Khcd is an isosceles trapezoid. So PE is equal to CB is equal to AB. And so that means ABPE is an isosceles trapezoid. And then that means ABTE is cyclic. Or I'll say E lies on ABT. Okay. And once we know that, we could say let H be the intersection of O1, O3E with AD. All right. And now we're claiming H is the orthocenter. So Anmol was saying, I'm trying to remember how you did the angle chase. So angle O1O3H is angle O1EH is equal to angle O1EA. So that's angle OEA or O1EA, which is 90 minus angle
Angle ATE.
ATE. And then where do we go from there?
Considering the fact that O1, O2 is perpendicular to TA and O1, O3 is perpendicular to PT, I mean ET, we followed that HO3 O1 is equal to 90 minus O2 O1 O3.
Okay, so we want to show O1 O3H. Yeah, so we want to show that this is perpendicular to this. So we want to show angle O1 O3H plus angle O3 O2 O1 is equal to 90. So we want to show ATE is equal to O3 O2 O1, basically, right? So that's 84, and that's, wait a second. So we have O1 O3H. We want to show that when you add that to O1, oh, okay.
We want to show that O2 HO3 is 84, yes.
Yeah. So O2 HO3 is equal to ATE. That's what we want.
That should follow from considering the perpendiculars in pair of O1, O2 and AT and O1, O3 and TE.
Okay, so O1, O3 is perpendicular to TE, and O2, O1 is perpendicular to AT. So yeah, we want to show
yes. O2, O1, O3 becomes 180 minus ATE.
Okay.
And that's the property of orthocenter.
Oh, because if you reflect.
Yeah.
Yeah, I think I've got it. So we have, let's see, 0103 is perpendicular to TE. And 0203 is perpendicular to TA. No, this should be 0102. So if you combine those two, that means that the angle between them is 180 minus angle ATE. Let me check that, just make sure that's right. But I think that makes sense. So that's 96. This is 84, and they add up to 180. All right. And then okay, so if we combine this with this, we get 01. Okay, so 0103H is or okay, I'll just write it like this. So that means 020103 is 90 plus 0103H. And then is it obvious from there? Is that right? How is angle 01EA 90 minus ATE?
Because O1 is the circumcenter of ATE.
Yeah, O1 is defined to be the circumcenter of ATE. Well, no, it's defined to be the circumcenter of ABT, but ABTE is cyclic. Just to answer Hakan's question. So is it obvious from here that
it's obvious if you let O1, O2 cut O3H at some point, it's easy to see.
Okay. So from
One
here,
outer, two inner angles.
One sec. Okay, so we want to show this is a right angle. Oops. Sorry. Okay, so we know, so this angle is, so if we do 180 minus both sides, we have 0301F. Or yeah, if we do 180 minus both sides, then we have, okay, yeah. So yeah, I'll say subtracting both sides from 180. Then we have angle 0301F is equal to 90 minus angle 0103H. And that means that O201 is perpendicular to O3H. And this pretty much solves it. So why is my LaTeX? There we go. Okay, so we defined H this way. Okay, so we know that O201 is perpendicular to O3H. And how do we know that, like you could say we make the same argument, but how do we know that H is the same point if you do it both ways? Well, I guess, yeah, we also want to know that, like, if we could show O1H is perpendicular to O203, that would solve it. So if we could show like O1H is parallel to TD, and that might just be an angle chase, because angle O1HA is equal to angle O103E. Yeah, you guys see what I'm saying? I wonder if there's like an additional step we need here, because like, do you see what I mean? Like, so I agree that O201 is perpendicular to O3H. I agree with that. But then how do
we can similarly do this for the other side?
Yeah, but if we prove it for the other side, how do we know that H is the same point? Because basically, we define H to be
we defined H to be the intersection of the circle.
Yeah, so I guess we have to show that. So if we let O1, O2, yeah, what would the right point be? So
O2 is the odd one out in this triangle, and we proved that O2O1 is perpendicular to O3H.
yeah.
So we can similarly derive that O1H is perpendicular to O2O3.
I guess the only thing I'm saying is E the same? Like, so look at how we defined H. Like, we didn't define H totally symmetrically, right? Like, we defined H to be the intersection of O1, O3E with AB. So if we
H is symmetric with respect to O1 and O3. So we can replace O1 and O3 wherever we did the steps.
But like, hold on just a sec. So, okay, so here we said let O1, O3E. So I guess what we would do is we would say let O2, O3E intersect AB. Or I guess what would be the symmetric way to define H? So here we define it.
Just replace, just flip O3 and O1 around.
Okay.
The whole angle chase stays the same if we consider directed angles. And we similarly conclude that O1H is perpendicular to O2, O3. And two sides are enough to uniquely determine the orthocenter.
Okay, so you're saying if we flip O1 and O3 around, if we swap points O1 and O3 in the above angle chase. Then we find O1H is perpendicular to O2, O3. Sounds good. All right. So with that, I will move on to the next one. All right. So Serdar wrote it out in some more detail. I'll check it out more after, I guess, after the session's over. All right. Thanks, Samuel. That was a pretty nice solution. So I will move on to the next one. All right. So this one looks kind of interesting. So, all right, we have a little over an hour left. So E is the midpoint of the segment. All right, so I'm going to draw the orthocenter. Okay, so E is the center of A and H. The in circle of triangle ABC. So we draw the tangency points. So they call it C prime and B prime. So yeah, obviously E is the center of this circle. I'm going to draw that in later. But they, in the problem, they call this B prime, this C prime. Let F be the reflection of E over B prime C prime. So yeah, I think it's probably worth drawing in that circle. Just a second. Where's my, so we know this is cyclic. And if we reflect E over that, where's the reflect? And we call it F. We want to show F lies on the line. Ah, interesting. So we want to show F lies on OI. So if we draw the circumcircle of ABC, let me, oh, actually there's two different circles going on here really. So that's cyclic and then this is also cyclic. So yeah, let me erase this other circle. I think I really wanted to draw this circle. So that passes through, does that really pass through? No, that doesn't pass through I. Let me hide some of the extra. Maybe draw this perpendicular also, J. Okay, so if we let O be the center of the big circle. Okay, so O is the center of, I think it's D. Let me check. No, the center of E. So O is the center of E. We want to show F, I, and O are collinear, basically. All right. So E, C prime, F, B prime is a kite. Yeah, E prime doesn't lie on the circle. Let me try to move it around so it doesn't. Yeah, it's hard to get E prime not to look like it lies on the in the circle. Yeah, you guys will just have to remember. Wow, it's really hard to make E prime I guess you just have to make a taller triangle. But then F kind of looks like it lies on the altitude. It's hard to get everything perfect. Wow, very tricky. Maybe that looks okay. What do you guys think? You guys all have to just remember that E doesn't lie on the end circle. Or maybe I could flatten it and expand it a little bit. I think that looks good. I kind of like this diagram. So this is like the Q point, I think, right? So K, H, and M are collinear, where M is the midpoint of BC. Let me call this M. So K, H, and M are collinear. E, C prime, F, B is a kite. So yeah, how do we show something lies on OI? Tricky, isn't it? I mean, we could let AI, so AI and OM meet on the circle, obviously. I wonder if A, oh no, that's not cyclic. So yeah, what if we do this? I don't know if this will help, but I'm just going to try it. No. That's a good picture. So I mean, I guess one thing we could maybe do is we could reflect all three of Fi and O over B prime C prime and so that those are collinear. So if I reflect O over B prime C prime, let's see what that does. Does it lie on the circle? No. Reflect A over B prime C prime. So yeah, there's all these different theorems on the line OI. So I bet if we knew more about them, there might be an easy solution to this. I think if you guys have read I-3435, he has that book. I don't know how many of you have read it, but it has like a whole chapter on the line OI. So I'm going to do what Serdar said. So if A prime is a reflection of A over B prime C prime, then A prime M, B prime C, and OI are collinear. And do you know if they're collinear on the circle? That would be interesting. I don't think so. Yeah, concurrent. So yeah, they don't concur on the circle, but they do concur. So one's a reflection of A over B prime C prime, the other's a reflection of E over. Proof is not easy. All right. Okay, but I think that might help because basically, yeah, we have all these reflections. So we want to show that if we can show that IF passes through L, so we want to show IF and L are collinear. Yeah, post the link to the proof in the chat. Because then, yeah, then that reduces the problem of showing that I, F, and L are collinear. And that seems like it might be a little easier. And I wonder if IM is parallel to A prime F. No, it's close. Okay, so the Euler line of the contact triangle. Okay, so I'm going to draw this point. So this is so I is the circumcenter of the contact triangle. Is H the orthocenter of it? No, not really. Yeah, what is the Euler line of the contact triangle? So I is the circumcenter of it. All right, so Serdar just posted the link to that problem, the solution of that lemma he just said. And so then if that lemma is true, then it's equivalent to showing that I, F, and L are collinear. Okay, so I'm going to draw, so A, I, and A prime are collinear. Okay, so we want to show I, F, and L are collinear. So L is where A prime M intersects. Yeah, how do we use A prime M? That's the tricky thing. So OM, yeah, maybe we could show OF and L are collinear. That would also work, right? I guess either way. I think I have some ideas here. So yeah, what if we reflect a bunch of stuff over B prime, C prime? I'm just thinking. Yeah, there's a symmetry here. So AL, A prime. I mean, basically, we just want to show can I delete AF? Yeah, I can delete AF. So yeah, K, H, and M are collinear. I don't know if we can use that. Is E the... Can we write E as the orthocenter of some triangle? Trying to think. Because then if we reflect it over the side, yeah, what if we, let me try this. So if I, I don't think that does much. But yeah, it's an interesting figure. Okay, so what's the best way to do this? Do we want to show F lies on IL? Do we want to show it lies on OL? Or do we want to somehow use both? So EI, no, I don't think that's going to help that much. So EM is perpendicular to GB. Yeah, there's a lot of information here. It feels like there has to be a way to do this. So yeah, what can we say about A prime? So AE A prime F is an isosceles trapezoid, so it's cyclic. I don't know if that does anything. Well, so AF prime is equal to the radius of that circle. Maybe that helps because, yeah, I want to show that A prime F is parallel to something. Like what if I reflected L over A prime? Let's see. Not sure if that does much. No. So I want to use the fact that I want to try to use the fact that FA is equal to the radius of this circle. Or FA prime. But I think I looked at this. I don't think AF prime and IM are parallel, right? No. Let's see. So yeah, we could reflect I over B prime C prime and show it's collinear with E and L. We could reflect O over B prime C prime. What if we tried reflecting this whole circle over B prime C prime? So let's see. I'm just going to try it just for the heck of it. And do it. Maybe it would help to draw the 9-point circle. So yeah, GDJM is cyclic. I don't know if that does anything. How do I use point F? What if I draw EF? Does EF meet OM on the circle? No. See, that's a tricky thing. But still, I wonder if I want to let EM meet OF at a point, and then I want to show. Just going to try to find similar triangles, although I think it might be a little tricky. So what if we did this? What if I draw this? It's I guess the figure is getting a little messy, but what if I try to show that like what if I try to show, I want to show that what if I try to show triangle EPF is similar to API? So I could try to show that EF over AI is equal to AP over EP. That sounds somewhat reasonable. It's not that easy, but it sounds like it at least makes sense. So AI over EF. We want to show that's EP over AP. Yeah, but that's not that easy. Because P is defined kind of weird. But we know, so IM bisects AN. This is a confusing diagram, I realize. I don't know how to make it better. Let me go back to what we had before. I'm going to delete this in just a second. I just want to check it out. IM bisects AN. We know that. I wonder if you consider the homothency that takes the N circle to the X circle, I wonder if it takes point F to L, because it takes O to I. I wonder if, let's see. I wonder if Fi over Fo is Fp over Fl. Yeah, I wonder if F is like the center of the homothency that takes the N circle to the do you guys know how to find the center of the homothency of two circles like this? I don't even know how you do that.
Center and circumcircle, incircle and circumcircle, or
yeah, what's the how do I find the center of the homothency that takes the incircle to the circumcircle?
it's on Kn. No, K, not Kn. If we let I, B prime, A, C prime cut circumcircle at some point.
Okay. Then it's this point, or
It's on.
Okay.
It's on Qn.
QN, all right. It's where QN meets IO.
Yeah.
Interesting. So it's not point F. Yeah, this problem looks a little tricky. Do you guys want to move on to another problem?
Yeah, if we solve fast, then we can come back here.
Right. So I'm going to, that's all the problems that I had chosen, but let's see if we can find another problem. Because we have 40 minutes left. This one looks like it might not be too hard. This one looks maybe too easy. Let me see if I can find something interesting. Oh, we just did this one. We did this one earlier. This one might be easy, but I'll just do it for now. All right. Let's see what year it is, 2012. Right. I'm not going to tech it up for now. Just okay. So we have this is another parallelogram problem. So A is the obtuse angle this time. So A, B, C, and then we can draw point D. Oops. Right. So we got a parallelogram there. H is the perpendicular from A to BC. That's H. The median from C in triangle ABC meets the circumcircle. Maybe I should just call this M for midpoint. Let's draw the circumcircle of ABC. And it meets it at point K. All right. Prove that Khcd is cyclic. It's interesting. It sounds easy though. Let's see. How do we do that? But I better not speak too fast. Let's see. Should we? So there's angle chase, power of a point, and let's see. Do we want to use angle chase or power of a point? Let's see. Or there's one more trick, which is to find another point that lies on the circle. Can we show angle KHB is KBC? Doesn't seem that. Let's see. So, or we could try to show it. So we want to show HCD is 180 minus HKD. So, but HCD, we want to show HKD is equal to HBA.
You can extend DC and cut circumcircle of ABC. We have a harmonic bundle, maybe we can use this.
So you said we have a harmonic quadrilateral?
Yeah, if we extend DC and cut circumcircle of ABC.
Okay, if we extend, so you want to see where something cuts circumcircle of ABC?
DC cuts circumcircle at some point.
So BC cuts the circumcircle.
DC.
Oh, DC, I'm sorry. I got confused there. So, okay, let me delete this circle just for now. All right.
AKBE is a harmonic quadrat, harmonic bundle.
AKBE. All right. Just gonna check it for a sec.
So EK is a symedian, right?
Yeah, that's harmonic. So EK
Is symedian at AEB.
Yes, EK is a symedian. Yeah, so I'll just draw it a little nicer. So yeah, AKBE is harmonic. Because the cross ratio AMB infinity is 1. So yeah. So AKBE is harmonic, and so we have a symedian. Let me try something. So M is the circumcenter of ABH. Maybe that would help. I don't know. We want to show that is cyclic. Yeah, it almost seems like it should be trivial because we want to show angle MHB is angle MDC, but MHB is MDH. Yeah, this almost seems too simple to be true. So yeah, I think it's, hold on just a sec. All we want to do is show that MDH is MDC. Oh no, we want to show KHCD is cyclic, not MHCD. I got confused for a sec.
To show DM is tangent to BMH. Maybe this helps.
Okay. So DM is tangent to DMH is what you're saying? Or EM is tangent to it?
BMH.
EMH. Okay.
BMH. No, it's B.
BMH. I'm confused, sorry. All right. That's that. Were you saying DM is tangent to it?
No, it's not true. Okay.
Okay. Yeah, maybe we should draw the point C prime. Maybe we should draw the reflection of C over M. I wonder if that would help. So that would give us a parallelogram there. I kind of like that. I don't even have really an idea yet, but so maybe it's like some radical axis theorem thing. So so these circles look like they can curve. Okay, yeah, I think that probably solves it somehow. Yeah, I think it's easy to show that those circles can curve. So basically we would have CF. Yeah, we want to use the radical axis theorem. Sorry, I'm going to delete point E for now, just because I think this might solve it. Although maybe it's not as obvious as I thought. So yeah, we know FHCD is cyclic because I think FAHB is a rectangle, it looks like. And so, yeah. Just trying to think. So yeah, and I'm just trying to. I feel like it has to be easy, but I'm just, yeah. Just thinking how to write it out. So
It's enough to show, actually, why didn't you delete that? It's enough to show FMH are collinear and it's trivial.
We show FM and H are collinear.
Radical axis theorem.
Okay, so let's say, yeah, we don't know this circle exists yet. So I'm going to call this F. Let's make some more space here. Let C prime be such that C prime ACB is a parallelogram. So C prime M and C are collinear. Let AC prime meet. Okay, so we drew in the circle after. So all right. And then so we know that FHCD is cyclic. So FH equals AB equals CD. Cyclic isosceles craft that's delayed. We want to show that K lies on that. FKH, ABC, and AHB. So the radical axis of ABC and AHB is AB, right? Are you sure those are the right? Let's see. So I'm gonna try out what you just said.
FH is the radical axis of.
So FH
is the radical axis of FKH and ABH.
Oh, so that shows that F, M, and H are collinear. But I mean, it's obvious that F, M, and H are collinear.
No, it's obvious, but the radical axis of FKH and ABC must be KM.
Yeah, so it's like power of a point.
C.
Okay, I see what you're saying. So yeah, it's so this means AFBH is a rectangle, and that implies F, M, and H are collinear. Yeah, so, and then we could just say FM times MH is BM times MA is KM times MC, and that solves it. So, yeah, we don't even need this line. So, FM times MH is equal to AM times MB is equal to CM times MK. And so FKHC is cyclic. Oh, I think we did need the part before. Yeah, so FKHCD is cyclic. And that solves it. All right. So we have time for probably one more problem left. So I will check this again. This is the one we did that where Animal had that really nice solution. All right. Let's try something different. Oh, I think I've seen this one before. I think this one is like pretty hard. Yeah, there's a couple good ones here. Maybe I'll do this one. What year is it? 2010. All right. Check. Whoops. Didn't mean to add that backslash. What's going on here? That should work. Okay. O is the circumcenter of ABC. Let me maximize. P and Q are on the altitude AB. If only there were an altitude tool in GEO. Although maybe they have a good reason for not having it. I don't know. So OP and OQ. Okay, so we draw the perpendiculars to AB and AC. Okay, so we're going to need to extend the altitude. Maybe I'll just let it meet the circumcircle at another point. G. I'll draw, yeah, the midpoints. And now I can hide a bunch of stuff. We're going to wait. Okay. So E and H are midpoints. P and Q, so this is, whoops. That's point P. I think there's like a segment drawn twice. Let's see. There we go. So this is P. And this is Q. I wonder if D is the midpoint of PQ. Nope. Well, actually, that's not. But no, it's not. M is the midpoint of BC. They do it like this. There we go. S is the circumcenter of OPQ. Interesting. Okay, so that almost makes it look like M lies on the circle, which is not true. S. We want to show that angle BAS is angle CAM. So we want to show S lies on the median. Kind of looks familiar a little bit. I guess we might as well draw the tangents, right? Because we want to show S lies on the median. Maybe it's worth drawing these. Okay, that also works. All right. We have O, M, and F are collinear. We have some cyclic quads. This problem looks kind of familiar. This almost looks like an IMO shortlist problem. Maybe it was an IMO shortlist, actually. I'm not sure. So we want to show that A, S, and F are collinear. Can we show, are P, S, and M collinear? No, because then Q, S, and M would have to be collinear by the same argument. But yeah, I'm trying to use similar triangles. So if A, S, and F are collinear, is there any other line through that we can draw through point?
It's enough to show actually DAS equal to MAO.
We have to show DAS is MAO.
That's easy because OM multiplied by OF equals to OA squared.
OM times OF is OA squared. Ah, okay. So have we solved it? I think you just solved it. So I'm going to write it out. So we have OM times OF is equal to OB squared, which is equal to OA squared. And that means that triangle AOM is similar.
Actually, I'm not sure if I solved.
Okay. We'll just write it out for now then. Triangle OMA similar to triangle OAF.
No, I couldn't solve.
Okay. Second. But that might be useful later. So we want to show DAS equals OAM. But OAM is equal to OFA. So we want to show OFA. Oh, no, we kind of just went in a circle there. Or wait, maybe that does solve it. So this means that OAM is equal to OFA, and OFA is equal to DAF. I think that solves it. Right?
But we didn't prove S is on AF.
Oh, you're right. Yeah, we didn't prove S is on AF, which is the whole thing we're trying to prove. Let's see. Is S on? No. Let's see.
Is ASD is similar to AOM?
Is ASD so
Similar to AOM.
ASD and AOF? Let's see. So ASD is 134. AOF.
It's Q. It goes Q.
Oh, I'm sorry. You're right. ASP.
No, actually, I said ASD. You chose Q.
Oh, I'm sorry. I keep messing up here. ASD and AOM. AOF. It was close. So yeah, what similar triangles can we show? I think yeah, PS and M were collinear. That would make it really easy. But if we could take the midpoint of PD and maybe draw it through point S, yeah, like maybe if that's the midpoint of PD, and we'd let IS meet this at point J, maybe we could show PIS similar to SJF. That might just be like a length chase. So we want to show JS over IS is IP is AI over FJ. It's a little bit ugly, I guess, but maybe it works. So is triangle POD similar to triangle ABC? I've seen this. I think POD is similar to ABC.
Yeah, POQ is similar to ABC.
Yeah, I'm sorry, POQ is similar to ABC. So really, that I have a feeling that kind of, because then JS over SI is kind of like by similarity. JS over SI, I think, is KO over OM, right? Yeah. I wonder if that solves it. So JS over SI is KO over OM. We want to show that AI over JF. Which is KJ over JF. So we want to show that KJ over, actually, let me just add in this point just to, so we want to show KJ over JF is equal to KO over, wait, is that right? KJ over JF. It's KO over, Wait, what did I do wrong here? So okay, J over. Doesn't, yeah, this feels like it should lead. Yeah, where am I going wrong here? So we want to show that AI over JF is IS over SJ. Oh, I think I had the ratios backwards. So we want to show, let me write this out. We want to show that JF over JK equals KO over OM. Let me write this out. Want to show JF over JK is equal to JO or KO over OM. All right. And that might be obvious because let's see. So JF's JM times JF is equal to J B squared. No. Hold on a sec. So JF. Yeah, this feels like it should be a good approach, right?
Actually, that's easy from trigonometry, I think, but I don't know the synthetic way.
Okay, so JF. What if we like subtract? So you think this is easy from two different lemmas. So OM, that's half the distance from A to the orthocenter. I wonder if I is the orthocenter. No. But OM is the distance from A to the orthocenter. What if we added 1 to both sides of this?
How did you write KO over OM?
So I'll write it like this. We want to show that, so we know that JF over, so I'll write this. So or actually,
I understood right. They are
Oh.
similar trapezoids.
Yeah, so JS over SI. I'm just going to delete this for now. I know we're almost out of time. Let me just finish this thought. So if we adding 1 to both sides, so I'm going to add 1 to both sides. KM over OM. All right, I'm going to stop here. I think we're pretty close. It's probably just some kind of a length bash. So thanks, thank you both for sticking it out. And yeah, this was a fun session. I know in the beginning we got off to like a really good start. We just solved a ton of problems. Then we got to some harder ones. But I think we were really close on this. So thanks again for participating, and everyone on YouTube. If you want to join these sessions, feel free to email me at mgreenb801@gmail.com. They're on Sundays at 10 a.m. US Central Time. And don't forget to like and subscribe. So have a good day, everyone.